So today we will be dealing with the thermodynamics is there in physics, correct? So already I have told regarding the basics of thermodynamics like isothermal, isochoric. Yes, all of these things has been discussed in adiabatic. Fine. So I think you should know what it is. So today we'll be learning about the work done, derivation in adiabatic process. So in adiabatic process, heat will be constant. So already I told in the last class, in adiabatic process, heat will be constant. So let's see the derivation of work done in adiabatic process. So we all know work is what? Force into displacement. I'll write on here. Work done is force into displacement. Force into displacement, correct? So F dot dx. Same thing. What I did in the last class, same thing. What is force? Pressure into area. What is pressure? Force upon unit area. So just cross multiply. F physically P into A. And I'm going to substitute this. dW. So to get the total, dW is a very, very small work done. To get the total work, what I'll do? I'll integrate. I will integrate. Integral of dW is what? W. Integral of dx is what? X. Correct? Yeah. So coming to this, let me just clear the drawing. Yeah. And same thing, whichever we did in the isothermal derivation, same thing only I'm going to do here. Work done is from V1 to V2 dW. dW is P dot dV. Correct? Now we know that PV is a constant for adiabatic process. Correct? PV is what? A constant. So PV power gamma. PV power gamma is equal to constant. Okay. And that constant I will make it as C. Constant is C. So what is my C? PV. So PV is equal to C. So what is my P is equal to C by V. And don't forget to put the gamma. Now this whole equation I will put where instead of P I will put C by V power gamma. So that's the only difference in this adiabatic process. Rest everything is same. Now coming to the integration part. We all know that integral of x power n dot dx is equal to x power n plus 1 by n plus 1. Correct? So C is a constant, so I'll take it outside. Here we're integrating with respect to what? V. So 1 by V power gamma. So this V power gamma, 1 by V power, this symbol, correct? V power V or V power gamma, I'll be taking it to the top. Just like, if I take this top, it will be V power minus gamma. It is just like 1 by x square. Can be written as what? X power minus 2, right? Then I'm going to integrate. So my n is my V power minus gamma. So minus gamma plus 1 by minus gamma plus 1. Then V2 and V1. So instead of gamma, instead of what I'll put? Instead of V, because we are integrating with respect to what V here. So instead of V, I'll put what? V2 and V1. That's all. Then I'm going to multiply C with the V2 as well as V1. Clear up to this? It's a simple integration only I'm doing it. Yes. And whichever is constant, 1 minus gamma plus 1 is a constant. I'll take it outside. Correct? Yeah. Now coming to my C is equal to what? PV power gamma. So instead of C, I will put what? P V power gamma. So if it is V2, I'm going to put it as what? If it is V2, I'll be putting P2 V2. If it is V1, P1 V1. So that's substitution. I'm doing it here. And we all know ideal gas equation is what? PV is equal to nRT, where n is equal to 1. Where the mole of gas is equal to 1, and PV is equal to RT. Correct? So instead of this P2, V2, I'll put RT2. R is a universal gas constant, so I should not put R2 or R1. That is wrong. Okay, then I will take what? R constant outside. I'll just clear drawings. So R into T2 minus T1. That's all. By 1 minus gamma. So we can stop with this itself. Clear? So this is a very simple derivation. We just know the basics of integration. Reversible and irreversible process. So obviously reversible process is a process which can be reversed, correct? But we have, if you write those words in the examination, we are not going to get the mark. So it is the process in which all changes occurred in direct process can be exactly reversed. Only if you write this technical term, then only they'll be giving us the mark. So when a direct process cannot be reversed, then that is a reversible process. Okay. Then coming to the very important thing, the heat engine. So this is very important because thermodynamics, if you're planning to write the engineering entrance exam or any entrance exam, let it be. Okay. So this is very important because you have something called mechanical engineering. So mechanical engineering deals with thermodynamics, ATD and BTT. That is, BTT is basic thermodynamics and ATD is advanced thermodynamics. Okay, so you have to study through Carnot cycle. So if you're studying for engineering entrance examination, obviously engineering type questions will come. Correct? So that is based on this Carnot cycle. So we got two things here, source and sink. What is it? Source and sink. Okay, so it's an ideal heat engine, the Carnot engine. Okay, so it has got mainly four main parts. One is a cylinder, source, sink, and insulating stand. Okay, yes. So cylinder will consist of a perfect gas. Perfect gas has to be filled in the cylinder. Source is the hottest part. The hottest part is source. Okay. The hottest part is source. That is my T1. Kindly remember this. And sink is my coldest part. Sink is my coldest part. So if you have to remember either of this, either source or sink, because we have got to derive one derivation or one problem where eta is equal to 1 minus T2 by T1. 100% for the entrance point of view, this question will be coming. Almost all the papers. Okay, efficiency is 1 minus T2 by T1. So why I am telling you hot and cold is, suppose the temperature is more, that more temperature you have to put in T1 respectively, the source, the hot, the more temperature. Less temperature, I have to put it in T2. That's all. The less is always on T2. Okay, so this is very, very important for the entrance point of view. And then we got an insulating stand, which acts as a separation. That's all. So it's a non-conducting stand basically. So on the insulating stand only, I'll be placing the cylinder on top of it. So this is the schematic diagram. Again, what I told you is this, the second one. Let me just, yeah, I think now it's coming properly. So this is what I told you, efficiency. This is eta. Eta is called efficiency. Efficiency is what output by input. That is my efficiency. 1 minus T2 by T1. This you have to remember. And one more formula here is efficiency is output by heat supplied. For example, output by input. For example, if I'm teaching you for 100 marks and if you are getting 90 marks in the paper, then your efficiency is what, 90%. So input is 100, but output you are getting 90. Suppose if you're getting 100, 100 by 100, that's it. So 100% is the efficiency. But for the engine and all, we'll get only around, for a Carnot cycle, we'll get maximum of 20-25% efficiency. That's it. Okay, so it's one of the lowest available efficient engine in the world. So currently not used. So coming to my efficiency, output work by heat supplied. So work by heat, W by Q. So work is nothing but change of Q1 and Q2. Correct? So Q1 is always the higher temperature and Q2 is always the lower temperature. So these two things also you have to remember in this. I hope up to this it's clear on what is being stressed out. If you're not understanding, no need to worry. So limitation. Limitation is the same thing whatever we did in chemistry. Correct? So it doesn't indicate which direction the heat will flow. That is not being covered. Correct? Then one more thing is the entire heat, why it cannot be converted into work. The entire there will be some heat wastage and everything. Correct? There will be some wastage of heat. Why efficiency is not 100%? There is also a drawback or limitation of thermodynamics first law. And coming to the PV diagram, this pressure versus volume diagram. This also you have to carefully see, because again for the entrance they can ask this graph, 4 graphs they'll give you and they'll tell you to identify the correct one. Now coming to the Carnot cycle. Isothermal expansion, adiabatic expansion, then 2 stages of compression. So there is 2 stages of expansion and then there is 2 stages of compression. In what? Carnot cycle. Okay. Yes. So in the isothermal expansion, so the source is, what is source? I told you, the major source of heat. Correct? So the gas which is there in the cylinder, which is allowed to expand exponentially. Okay. So there is isothermal, I told you what temperature is constant. So the heat, correct? The heat molecules, correct? The heat molecules are transferred to where? To the cylinder gas. You got the point? Correct? So temperature is constant. Whenever you hear isothermal, temperature is constant. Second thing is adiabatic expansion. So adiabatic expansion, what is constant? Heat is constant. So here the cylinder is placed on the insulating stand and the gases are allowed to expand adiabatic. In the sense, all the gas molecules will have the same temperature. Again, this I am telling you ideally, not practically. Okay. But here it's going to transition from source to sink. So there will be a slight reduction of temperature. Then next one is isothermal compression. Isothermal compression, again, what is maintained? The temperature is maintained. The temperature is maintained. So the gas is being again compressed. Okay. And then I told you what the sink, right? Correct? Where it's a cold part. So a certain amount of heat will be released to the sink here. Next part is isothermal compression. That is again towards the isothermal compression done. Now next word is adiabatic compression. From D to A. D to A is my adiabatic compression. So the adiabatic compression, what is the main thing in adiabatic? Heat. Heat is being preserved. Correct? So till it returns to the initial state. What is the initial stage? A. It has been adiabatically compressed. And this cycle will follow. That's all. This cycle will be following. So you have to know this graph properly, because for the exam they might ask you regarding the Carnot cycle. Very important. Clear? Next one is prove that efficiency is 1 minus T2 by T1, which I already told you. We know that Q, what is the formula? W is equal to RT log of V2 by V1 to the base E. So this already we have derived it adiabatically. Correct? So W1 and W2 you have to know, and here we have to know, we have to get one more thing called W3 also. So one is V2 by V1, correct? Which is W3, it will be V3 by V4. V3 by V4 respectively. So these 3 equations just keep in mind, and here then W4. So W2 and W4 are represented by what? R into T1 minus T2 by gamma minus 1. By gamma minus 1, and this will be R into T1 minus T2 by gamma minus 1. So what we can see is W2 and W4, correct? They're almost same. Efficiency, output by heat supplied. This already we know it. 1 minus T2 by T1 or 1 minus Q2 by Q1. Correct? Q2 by Q1. So substitute the Q2 and Q1 value from the equations 1 and 3 respectively. 1 and 3 respectively. Okay, so once you do this, then we know that adiabatic expansion T into V power gamma minus 1 is equal to constant. So here T1 V2 gamma gamma minus 1 is equal to T2 V3 power gamma minus 1. Now I have to do what? 1 minus T2 by T1 I have to do, right? So T2 by T1 I will do it. So just T2 by T1 is what? From this. From this, take T2 by T1. T2 by T1. Then get other things on other side. And make sure this is gamma minus 1 is gone to this side. So it will become 1 by gamma minus 1. So only once you do it only, you'll come to know. Any doubt is there? Once session is over, I'll help you out with the same. Similarly, T1, T2 is gone. Correct? That is the second stage of adiabatic expansion. Now for the compression part, T2 by T1. So I'll directly take what? The first and the fourth. The first and the fourth. The same thing will come. V1 by V4 power gamma minus 1. You can directly write it down just by changing the number. Instead of 2, put 1. Instead of 3, just put 4. That's all. Okay. Yes. Now LHS is equal. T2. Yeah. Once we do that, we'll be getting 1 minus T2 by T1 respectively. That's all. So any doubt is there, I'll help you out in the same.